Okay, hello everybody. Welcome. Thanks for coming today. This is the PDHP workshop called Sequence Analysis for Social Science with Annetta Fasang and Emanuela Struffolino. Appreciate your interest today. We've got a great workshop that we're really excited for this morning, and so really appreciate you being here with us today. I just want to take a very brief couple minutes here this morning just to kind of introduce myself and introduce our center. We're a young and kind of growing center, so I'd like to take a couple minutes while I've got your attention just to kind of let everybody know about the services that we offer, and then I'll disappear and hand over to our presenters in a couple minutes. So I'm here on behalf of the Population Dynamics and Health Program here at the University of Michigan in Ann Arbor, Michigan. That's who's hosting the workshop today. And I want to take a moment to thank our funder, the NICHD, the National Institute for Child Health and Human Development, that supports the free services that our center offers, including this workshop series. So my name is Paul Schultz. I'm a data scientist and statistician here for the center. And the center primarily works to support population research of all kinds. And so anything that would sort of be up the alley of the NICHD, particularly the population dynamics branch, we're charged to sort of help that research here at the University of Michigan and the surrounding institutions and centers that wouldn't have their own population center. And so some of the free services that we offer are a career development program. We just kind of accepted applications for that early in the year. So unfortunately that deadline has passed, but if you're interested in that, you should check this space again next year at this time. That's a program where we paid early career scientists. We sponsor a little of their time for a year and sort of set them up for a mentor here that's a successfully funded population scientist. And so if you're interested in something like that, again, that's a service we offer that you can find on our website. We also offer free consulting in really for any technical aspect of population research. So we consult on sample design, experimental design, machine learning, survey weight creation, all sorts of things that kind of fall under the umbrella of population science. And so we offer that for free to our affiliates. We've got an affiliate program that you can apply to on our website here. And then we also offer we have a team of analysts that we're able to loan out on projects. And so if your project needs kind of rise above and beyond what we're able to do in a consulting hour, we've got actual analysts on hand that we can loan out to your project and actually do work for you at cost. So that's another service we offer. So again, I don't want to take too much time. If you've RSVP'd for this workshop, you've seen our website and you've at least touched it. So if you've got questions about anything that I've described, please feel free to reference our website. It should be all there. And if you want to discuss with me, that's fine. You can reach out to me by email and we can set up a time to talk. So that's it for our center. Before I go, I want to let you guys know that we've got a workshop series that we hope to run throughout the year. So this is our first one of 2022. We were a little bit interrupted due to COVID, but we've got some other workshops lined up for the year. And our next workshop will be March 28th on reproducible research with Alexandru Surnat, who gave a similar short course at APOR last year. And so he's doing our workshop. That will be on March 28th. And so if you're on our mailing list, you'll start seeing promotions for that come out sort of at the end of this month here at the end of February. And so please be on the lookout for that. And we've got other kind of workshops planned for throughout this year. So if this is something you're interested in, there should be some good content for you throughout the year. So on that note, I'll go ahead and introduce our speakers for this morning. We're very lucky to have these two women, very, very, very distinguished folks here for our workshop series. And so I'm really excited for today. So let me introduce our speakers for this morning. So Annetta Fasang is a professor of sociology at Humboldt University in Berlin. She got her PhD from Bremen University in Germany and did postdoctoral research at Yale University. She also led a research group on demography and social inequality at the WZB Berlin Social Science Center for many years. She has been active in the sequence analysis community since her dissertation research, and recent publications have appeared in the American Journal of Sociology, Demography, Sociological Methods and Research, and Sociological Methodology. And then our other presenter is Emanuela Struffolino, who is an assistant professor of economic sociology at the University of Milan in Italy, the Department of Social and Political Sciences in that university. From 2015 to 2019, she was a postdoctoral fellow at the research group Demography and Inequality at the WZB Berlin Social Science Center at Humboldt University in Berlin. Her research focuses on social stratification and inequalities over the life course. And so thank you very much. On that note, I will hand over to our distinguished presenters, and I appreciate you being here and enjoy the workshop.
So good morning, everybody. I think I will start. Thank you very much for the invitation. Thank you very much for the kind introduction, Paul. And it's really great to see so many of you here. I will start with a personal note. I'm really excited to teach this here, especially at the University of Michigan, because my mother got her BA at the University of Michigan in music in 1968, and then her Doctor of Musical Arts in 1971 at the University of Michigan. So even though I've lived all my life in Germany, we'll talk about life trajectories a bit throughout the course. There's some deep connection to Michigan and this place. So let me start by sharing my screen. So what we'll do today is really a very basic introduction. So actually, Emanuela and I met when I was teaching a sequence analysis class maybe 10 years ago in Berlin, which was then already 2 days. And Emanuela has been teaching many of these classes with Marcel Raab together. They have been up to a week long, so one can easily fill a much longer time than 4 hours. But what we're going to try to do today is give you a basic idea of what this method can accomplish, what kinds of questions it's useful for, how to get started with some hands-on code, and we will provide you with many sort of avenues for future research if you're interested in going deeper into some of the details. But it will be a fairly basic overview here. We'll go a little bit back and forth. I will start with a basic introduction to sequence analysis, then we'll have a hands-on part, then we'll have a presentation part again, and then a hands-on part again. So if you have questions, as I said, please feel free to post them in the chat, but also raise your hand. We're happy to take questions throughout. Good, so in this first part, my aim is to place sequence analysis in context. So with theory and methods, what's the theoretical background, the motivation here, and where does it fit in with other methods, specifically for longitudinal data analysis. And then we'll talk about some basic sequence terminology. Before we get started on the theory, let me show you a simple example here. As demographers, we're very much used to working with numbers like age of first birth, transitions to first birth. What you see here are 2 family formation sequences. These are actually sequences from real people from the National Longitudinal Study of Youth, American data, where we observe people from age 22 to 44. You see the state they are in is color-coded. We have a person here who has a partner but no child. Then they stay together and have 1 child, but that's it. And another person starting out in a relationship also at age 22, but then breaking up and remaining single and childless for the remaining period until midlife. So when we talk about sequences, this would be a classic example in demography. This is the type of sequences we mean, following individuals and the states they go through over extended periods of time. Now here you see 2 sequences where there's really only 1 transition in their entire family life course, the way we measured it here. But when we look at other people, here we have 10 sequences. There are, of course, lives where there's more going on, where just a simple transition perspective misses out on a lot. For example, when we have single parents or individuals who break up and repartner or have multiple children. Here you see these 10 sequences. I will show you now the full sample of women born 1957 to 64, their family formation sequences, which, as you see, is very rich data. Here they are sorted by the age of first birth. That's the blue line you see here, like a transition rate. You could also imagine from an event history graph, but here we see all the other transitions kind of happening around them. Now, the goal of sequence analysis are coming from demography. We have this really rich longitudinal data here, And sequence analysis is a tool to try to find patterns and make sense of the complexity in this longitudinal data. For example, here, one classic approach would be you start out with a mess like this, kind of looking like a Persian rug, and lots of information in here on timing and order of these states. And then we can group them into ideal types of family formation. So like down here, you would see early single parents, a lot of repartnering. So green is the single parenting interrupted by some repartnering. And then up here, we have relatively late partnering and then an orderly transition to the first and the second child. And for example, here we have these several ideal types of family formation that I sorted now by those with the lowest earnings at the bottom to the highest earnings at the top. But so this is one of the classic things sequence analysis then will allow to do you to find groups of similar ideal typical sequences. Let me just briefly check. I'm having trouble seeing the chat, but okay, no questions for me so far. Now I have it here, so now I should also see your questions. If you have questions in the chat, but please also feel free to raise your hand. Now this is a very standard application in demography, but where sequence analysis originally came from. So the method as such was invented in biology long ago to study strings of DNA. But Andrew Abbott adapted it for the social sciences in the mid-'80s, late '80s, and then especially throughout the '90s. And he had a much larger theoretical motivation behind it, focusing on process and giving processes, temporalities and temporal processes a more prominent place in social science more generally. So some of his influential publications here include an essay or a book called Time Matters, where he argues that process and mechanisms that unfold over time are the fundamental building blocks of sociological analysis. I quote him now, social reality happens in sequences of actions located within constraining or enabling structures. And he packaged this whole idea of pushing for a more processual perspective on all sorts of social processes in an idea of narrative positivism, where it's still positivist in that we're working with data, we're observing the world and also with quantitative data, but that we should look at the processes and not what he calls the general linear model or the general linear, there's a famous essay, Transcending General Linear Reality, which he calls the variable and regression-based approach that he says misses out on a lot of the temporal dynamics that are actually very important in many social processes. So Abbott's work, of course, has been extremely influential in many, many fields. His initial argument for this more processual perspective and then introducing optimal matching also met a lot of criticism, maybe partly because he was heralding it so strongly as this new view on the social world, where in the meanwhile, it's become more established to think of this as really a complementary approach to the variable-based approaches. And there are a number of new methods that actually try to combine the two. But let us take a little time to think more about what was meant by this processual approach in social science. So Abbott says, by a processual approach, I mean an approach that presumes that everything in the social world is continuously in the process of making, remaking, and unmaking itself, and other things instant by instant, so that we should always have this dynamic perspective, for example, on the family formation trajectories, observing the whole walk here. The world of the processual approach is a world of events. Individuals and social entities are not the elements of social life, but are patterns and regularities defined on lineages of successive events. And then a very important concept is the concept of a process outcome. So a process outcome, as opposed to, let's say, a more static outcome would be to look at income in a given calendar year or an income distribution. But process outcomes are long-run stabilities established by myriads of individual events. it's the whole walk that is the outcome. And if you think about the family formation sequences I just showed you, and these ideal types of different processes, you can think of these as a process outcome. Basically, they are a typology, a simple categorical variable that summarizes processes. And then you can use these also as dependent or independent variables in regression-based approaches. All right. So the most common fields of application to date certainly have been life course sociology and life course research. Abbott already in the 90s writes that life course studies have such a central theoretical place for the idea of trajectories and process, but the empirical methods haven't picked up on that much. And this has really changed in the last 2 decades, not only with sequence analysis, but prominently also with sequence analysis. Family demography has seen a lot of applications, and the reason is, as we will emphasize throughout, sequence analysis is a method to look at sequences of categorical, so qualitative states, something like being in a relationship or not, whereas we have other methods like group-based trajectory models that might be better suited to look at metric or binary outcomes. But especially in family demography, because family formation is a categorical or qualitative process, here these types of variables are very important. I think that's one of the reasons sequence analysis has been so prominent here. Then we see a lot of applications in labor market and career research, social stratification more broadly, but also in aging and retirement and welfare state and social policy analysis, where then the questions are, how do specific types of welfare states or policies shape life course outcomes or shape different processes over time? And then there's another field where we're seeing more and more applications, which is time use research. And there I brought you an example from some recent analysis that we're work in progress that we're doing on German time use data at the moment. So what you see here, for example, is a typology of children's time use on weekdays. So they get, it's from 6 a.m. to midnight. And then we see here, for example, the blue is screen time, kids who basically watch TV all day long on weekends. The yellow and here are lunch and dinner, that's eating. But we also have kids who do chores or cultural activities or social activities, for example. So this would be another area of application. And then you come up with these typologies. And here, for example, we can look at gender differences, but also how they changed over time. And surprise, surprise, for example, the all-day screen time cluster really did get much more prevalent among younger cohorts of kids, whereas social activities have gone down. But so these are some main fields of applications. One thing that's really, I think, interesting about sequence analysis and makes it such a pleasure to be part of this community is that we see very many different applications. There are also a famous study by Kate Stovall on regional patterns of lynching in the Deep South. There's one by historians on Holocaust survivors and their trajectories during the Second World War. There are quite a few in cultural sociology, but also increasingly in political science or in history. And I saw Peter Flügel here earlier, a historian we've started to collaborate with on, for example, the Jaina monks in India and their trajectories. So that also makes it always really fun to be at these sequence analysis events because you get a great interdisciplinary bunch of people who are interested in all sorts of processes. Yeah. I'm having a little bit of trouble with my, here. I briefly want to walk through connecting the sequence approach to the life course paradigm because most or very many sequence analysis studies also in demography somehow base or motivate this approach also in the life course paradigm where we have a very clear link between some basic theoretical propositions and what the method has to offer. So some of the core principles of the life course paradigm are that development is a lifelong process. So it's always complicated to look at an outcome you're interested in at only a specific time in the life course. because the volatility of this outcome, let's say, be it income or life satisfaction or some other outcome, might be of much more interest, how this varies over time than where it is at any given time point. Then the life course paradigm also places great emphasis on the so-called principles of time and place. So what individual lives look like depends on the timing of events and the macrostructural context within which they are placed. For example, the timing and sequencing of life course processes matter for their correlates and consequences, whether I have a child at age 16 or age 35, and whether I completed education before or not, obviously are very consequential for what happens after this transition. And then there's, of course, also a lot of theoretical reasoning about life course norms, ideas that we have about the appropriate timing and sequencing of events. Here, there are some very interesting early studies by Peter Behrman and Hannah Brückner, where they use that health data, for example, to ask young adults, what's your ideal romantic relationship sequence? And then the young adults put down cards of first holding hands, exchanging gifts, meeting parents, and so on. And a few years later, they asked them about their actual romantic relationship sequences, and then these could also be compared. But this is also an important point here, that there are explicit norms about when in the life course and in which order things ought to happen. And our institutions are also built up to reward a specific timing and sequencing of life events. And finally, there's a big literature, of course, around the idea of cumulative advantage and disadvantage in the stratification literature, but also considering health inequalities. And here the processual perspective, or looking at full processes with a sequence approach, has also proven very fruitful. Core theoretical concepts, and this doesn't only have to be in the life course field, that sequence analysis immediately speaks to is if you are interested in the timing and sequencing, so that is the order of events. Then there are many questions where we might be interested, what happens if individuals go, or also organizations or other units of analysis, go through the same process, so the same order of states, but at a different speed. For example, I was just talking to some political scientists who are studying whether in the global south, when countries, everything happens there at once, transitions to capitalism, democracy, digitalization, if everything happens at once, if that has very different consequences because there's sort of a system overload, as opposed to if different things on the societal level are introduced with some longer gaps between them. So this would be one of those questions. How does the speed of a process matter? Then if you're interested in zigzag processes or back and forth movements, here, for example, in economics, Jacob Hacker's work on economic volatility. So he basically argues that yes, income inequality has increased in the United States and elsewhere, and this is very significant. But even more important has been an increase in economic insecurity and in the volatility of income. For example, these types of volatility, instability, or precarity concepts can be directly addressed with sequence analysis very well. I already talked about cumulative advantage, disadvantage, path dependency, also, so when we have processes where not much is happening, or when an initial event very strongly determines the subsequent trajectory. This is also something political scientists tend to be very interested in. Then we have the quite controversial concept of turning points that Abbott writes about a lot too. So what are critical turning points that set off entirely different trajectories afterwards? Or as I already showed you with the family formation, when we're interested in finding ideal types of complex processes over time. So these are some theoretical concepts or interests where sequence analysis probably can be of use for you. Now, turning to methods. At this point, are there any questions? Maybe go answer about the, Elizabeth has one about sequence analysis and Markov models. That's right. So I will talk about this actually more when I go more into the methods. So sequence analysis tries to capture the sequence but doesn't model them. So there are some attempts to simulate sequences with hidden Markov models that people like Satu Helske at the University of Turku are working on. But I maybe come back to this after my next part here on placing sequence analysis in the context of other longitudinal methods. So coming from the life course world, there are basically 3 standard longitudinal methods many people work with. This is also in demography, of course, event history or survival analysis, where we model whether and or when events as the transition to first birth occur. Then we have panel and growth curve models, more recently also group-based trajectory models, where we're looking at how does one outcome change over time, let's say income, occupational prestige, but it also could be a health indicator or any type of metric or binary basically indicator. This is also important. The group-based trajectory models here are different from your usual panel or growth curve model in that they also try to identify groups of typical trajectories, but they are useful if you're studying, for example, income or work hours or a metric outcome. Sequence analysis really comes in when you're interested in processes of categorical states, and for analyzing trajectories or stories as a whole. So it's not just the process, but it's also the categorical states. Abbott also talks about this as multivariable regularities, whereas in the other approaches, we usually have one dependent variable, one dependent construct, whereas these sequence types then really are multivariable summaries. Now, if we briefly walk through these 3 methods, in event history analysis, of course, the theoretical concept we're interested in is a transition or the duration until one specific thing happens. In panel regression, it's change over time, but with a binary or metric outcome. And in sequence analysis, it's a trajectory of categorical states. Now, coming to the scientific tradition these methods are rooted in, they are quite different. So for the event history or the panel regression, where event history, of course, in the end is also a regression-based method, just it's the rate that's the dependent variable. We are in the world of the stochastic data modeling tradition. And with sequence analysis, it's more this idea of narrative positivism or an algorithmic tradition. And this is important because they make very different assumptions about data generation. So in the stochastic data modeling tradition, there's an idea that there's some kind of stochastic process that is generating variables that have a specific distribution, for example, a normal distribution. And there's also a strong sense of that some causal process is generating the distribution of these variables that we're observing, even if we can't identify this causal process, that's what's going on. And there are assumptions about distributional assumptions, and we all know them who work also with these types of methods that then sometimes, or actually fairly often, they are violated, and then we have to deal in some way with the violation of these assumptions, these distributional and other assumptions that these methods make. Now, the algorithmic tradition where sequence analysis comes from makes no assumptions about processes that generate the data. That's simply a black box. It's in that sense, it's more in the tradition of data mining, algorithmic models that try pattern search. We approach the data without any prior assumptions. And this is also an advantage because then there are no violations of assumptions that we have to deal with. But of course, it also comes with limitations, but it's a whole different way of approaching data. So in the event history framework, our objective is to identify the timing of single transitions or durations. In panel regression, we're looking at change in our one outcome or the probability of divorce or something like this. And in sequence analysis, what we're trying to find are patterns of sequential equivalence. This, you can understand this similar to structural equivalence in network analysis. So patterns of sequential equivalence would be groups that have the same go through of people or entities, whichever are your units of analysis, that go through the same types of processes. And there are, now this doesn't apply to every application in all of these different fields, but there are some broader theoretical assumptions here that I think are useful to keep in mind. That in the event history and panel regression framework, we often assume that there is some sort of structural environment that impacts the occurrence of or the change in events. So it's basically structure, that be it a policy change or something else, something that happens to the individual that then leads to different behavior that we then observe in terms of these transition or change outcomes. Whereas in sequence analysis, the assumption is more that structure and agency constantly interact. So when I look at a life course process, of course, it will matter whether I'm born in an affluent or a poor neighborhood, whether I have access to high or low quality education, whether parental leave benefits are available or not. So structure matters. But in these long sequences, of course, individuals also actively make choices that interact with the opportunities available to them. So the idea would be more that we have a continually mutually interacting relationship between structure and agency that jointly produces the sequence that we observe. I think the advantage here is that we are kind of taking a big picture perspective on these processes that result from these all of these different relationships and influences. But of course, this comes at the cost that we don't zoom into one specific relationship, which is more what you would then do with the event history or panel regression framework. So sequences, as we understand them in sequence analysis, are empirically observed traces of temporally ordered events. So it can be really all sorts of events. It doesn't have all sorts of units of analysis, but they have to be somehow ordered temporally. And the goal is to analyze these regularities in categorical sequences. So there's another point here that I think is worth highlighting, that these categorical states often are qualitative states. I mean, we can have, for example, income brackets or things like that too, but whether you're single or not is a qualitative and not a quantitative state, clearly. And sequence analysis in that sense is at the intersection of qualitative and quantitative methodology, because we are basically taking a quantitative method and doing a quantitative analysis of qualitative information. And this is also where this is its great potential, but for that reason, for example, it's not so trivial to put confidence intervals around results, for example, these patterns. And a lot of these established data validation or thresholds we're used to from the stochastic data modeling culture do not straightforwardly translate into the sequence analysis world. So here you just see a few examples of categorical states. We have employment careers, where often there's a mix of qualitative and quantitative information. So whether people are on leave, unemployed, on permanent or fixed term employment, these are states that are often difficult to grapple if you want to look at multiple of them in a more metric framework, but then you can combine them, for example, with income brackets. Another area where we see a lot of sequence analysis studies have been pathways to adulthood and residential arrangements, living with parents, leaving the parental home, then on different dimensions, how this intersects with completing education and so on. Family formation and time use, I already showed you examples. So let's move to basic terminology in a little bit of a more formal sense. Or are there questions? Oh, I see 15 in the chat. Is there anything we should talk about?
I addressed all of them.
Okay.
Go ahead.
So at this point, no questions we should talk about. Okay.
Maybe there is one more theoretical that fits here better than the Q&A, as I thought.
Which one?
There was a question about Abbott's early work and the fact that he sees social processes as sequences of events. But in later work, he uses term the lineage of successive events and seems to take non-sequential view on temporality. And this arises from a previous part of this. Yes?
You go to the post office?
No, there's.
Yoon, do you want to raise this point again? So which later work do you mean? I mean, the processual sociology book in 2016, which is, of course, many of the essays he wrote earlier. I think there he makes very clear this processual approach, but it goes beyond. For him, sequence analysis is one tool to look at some of these processes, but it's clearly not sufficient. So there are also processes you cannot really get to with the sequence analysis approach that he's interested in, I would see, but I'm not sure which work you mean with the where he's arguing for a non-sequential view.
May I explain a little bit further?
Yes, please.
Yeah. Yes. I think in his book, Time Matters, and he argues about the sequence, prefers the sequence analysis to analyze the social processes in its entirety as a whole process. And in his later book, Process Sociology, he seems, instead of a sequence analysis, he seems to prefer ecology, sociology. So as the system, and not only future, not only past sequence of time, but also the thick present. So past is only encoded in the present, and then the future, the projection also in the term of a thick present. So in that, so every decision at the moment is the different tempering order, not directly from the sequence of past events. So I'm not sure if he's still, I don't know if he changes his views on sequence analysis, or he still uses a sequence analysis, or how do you match this whole sequence analysis method into his the process ontology?
Yeah,
focusing on present.
Yeah, I mean, I think his processual approach clearly is much broader, and you're right, especially in the more recent theoretical work. He also looks at future orientations, past orientations for actions, or in different theories and so on. And he follows the sequence analysis work and is interested in it. But for example, he says he's been out of the technical details for a long time and is interested in many different things. Of course, I think for sequence analysis, an important point is that there is some theoretical foundation here to argue for these process outcomes, and where he very nicely shows how a more static view focused on one point in time or single transitions misses core things that we might be interested in as social scientists. So I would see sequence analysis as one of the technical innovations he brought to the field in the 80s and 90s that address a small set or a part of his theoretical ideas, but obviously not all of them. And I don't really think there's a contradiction here.
Thank you.
Yeah, you're welcome. So let's go a bit more into the technical details here. Basic terminology: what is a sequence? An ordered list of a discrete set of elements. And here in the sequence analysis jargon, we talk about a state space or an alphabet A. So it's an alphabet because these are always qualitative states that can also be expressed as letters and not only as numbers. And a sequence of length x and of a sequence x of length k can be written as follows here. And then we have our state space would be A, and this would include states, for example, as being single, being divorced, being repartnered, or being married. Yeah, most social science applications are interested in recurrent sequences, which allow for repeated occurrences of the same state. So obviously you can be divorced or married multiple times, for example, but there are also some where states cannot recur once they happen. So depending on what you're interested in, this is something you might want to consider. Some other basic terms here that are familiar from the event history world are episodes and transitions. So here, for example, you see two sequences coded with our alphabet of S being single, LAT, living apart together, which would be dating but not living together, cohabiting and married. So this would be our alphabet of states. And then in sequence A, for example, we have first an episode of being single for 2 time points, then there's a transition to living apart together, another transition to an episode of cohabiting, and so on. So sequences consist of multiple episodes or spells and transitions between them. And what we already see here, of course, we have a duration in different states, but then also a different order of these states. Now, there are different ways these can be stored as data, different formats, and this becomes relevant because your statistics program, so there are possibilities to do sequence analysis in Stata or R, and they will require a different formatting of your data. And it's also relevant because it affects how large your data gets. So let's say here you have a partnership sequence, family formation sequence of length K equals 2264 months. So let's say we had monthly data, which we often do in these retrospective demographic data sets. And this would be one way to store them simply as a really long string where each time point and each state is stored as its own variable in a way. That's the state sequence format, which of course, if you have many sequences and long sequences, can get quite large. A more efficient way of storing your data would be the state permanence sequence format, where you put in brackets every episode and then its duration after a colon. So this is a way to store your data that R can also easily work with, that of course saves you a lot of room and has exactly the same information as what I showed you before. And then another way, which is already a data reduction, is the distinct successive state format, where we only look at the order of different states and basically strip them of the information on timing. So this is one thing you can, for example, easily do in R if you're only interested in what is the order of states, not at all how much time people spend in it, then you simply take out the timing and only look at the order. Now, defining your sequences in the beginning and the sequence alphabet is a very important step, and I think it hasn't gotten enough attention in many applied studies. It's basically the decision of which variables do I include in my model, and of course what you can find will greatly depend on what input you put into the analysis. So usually it has been shown that it's useful to have between maybe 5 and 10 states. I mean, it depends. There are also analysis, for example, on time use that only distinguish 2 states, work and non-work, and then look at how they vary over the day. And this is really a great study by Laurent Lesnat from Paris, Sciences Po. So there are very interesting applications only with 2 states. And if you have very many states, the analysis often gets a bit unwieldy and it becomes difficult to extract main patterns. Just as some practical guidelines, it can often be useful to combine states that are very infrequent or substantively not so relevant into one category. If you have very many states that only occur very infrequently, it won't help you to find the main patterns in the data. So I think this is another point to keep in mind about sequence analysis. you are trying to find main groups in the data, and these main groups will have fuzzy edges. And then you can also have indicators of how strongly individuals fit into their group, and you can identify outlier life courses and things like that. But for the main pattern search, it's often not helpful to have very many and very specific infrequent states. Also to keep in mind, large alphabets lead to less stable cluster results, especially when case numbers are small. So we're just running some simulations that we're cross-checking with very huge register data samples from Denmark and Finland. And here we found that basically if you have up to 9 or 12 states with sample sizes above 1,000, the cluster analysis results are stable. But if you only have a sample of 500 or 600 sequences and very large alphabets, the cluster results become very unstable. So you also have to balance these to some extent. Then often we have things happening at once, overlapping states, individuals who, for example, are doing an internship and working 3 different jobs at the same time. These can be combined to be their own category, which depends, of course, very much on your substantive research interests, whether you want to do that or not. But here it's very important that you spend some time on considering how you define your alphabet of states. But often, of course, data limit what you can actually do. Now, sequence length and the time intervals are the next point you need to make choices about. So what defines the starting point and the end point of a sequence? Here, you can either look at process time, so a sequence starts at a given age or a specific transition. For example, I just saw an application, a very nice one, looking at couples' division of labor after the birth of their first child. And they simply looked at the first 5 years after the birth of a first child. So this would be a process time specification. But what is very often done in demography and life course sociology is you just say age 20 to 35, age 15 to whatever, some age bracket. This is also very useful because if you have a good process time start, like the one was the birth of the first child, but then looking at the parent sequences, this works because they are comparable and in a sense that you observe the process you're interested in for everyone. But sometimes, for example, if I compare labor market trajectories, and for some people I have an age bracket of 20 to 30, and for other it's from 40 to 50, this is not very meaningful necessarily because late careers are very different from early careers. And so I might be able to find this if I set up the analysis in this way, but there are often problems with analysis that look at entirely different age brackets for different individuals in their sequences. So here you just have to be careful in thinking through whether this really makes sense. Then the time intervals are often dictated by data. We have yearly or monthly data. But for example, we've been applying sequence analysis quite a bit to register data. These are very detailed, large data sets, of sometimes even on a daily basis on benefit receipt. And sequence analysis is very useful here because you have these very large, complex longitudinal data to find some main patterns and identify these temporal processes. But here, if you have, for example, daily information, your data also gets extremely large. And so then it can be useful to, for example, collapse to a weekly or quarter yearly time granularity. So it depends really on how much change there is in your data, also if you need a monthly or a yearly time specification. So just a brief note on sequence lengths and time intervals. The alphabet size and the sequence lengths together define the number of possible sequence realizations. So just theoretically, they probably won't occur all in your data, but what would be theoretically possible in terms of which sequences could exist, of course, depends on your alphabet size and the sequence length, and it increases exponentially, basically. So if you have 10 elements in your alphabet and a sequence length of 10, you have very many possible sequence realizations. And I think this is also interesting when you look at the sequence data I showed you, for example, the family formation sequences, the first one where it's just the entire sample, you think, wow, there's a lot of variation going on here. These lives are so chaotic and so different. But if you think about the theoretically possible number of sequences that could arise in most specifications, it's much, much greater than what we observed. And there's actually a remarkable patterning and a remarkable amount of structure, I think, in at least many of these life course and family demographic processes that we observe. Yeah, just briefly, a common problem is unequal sequence lengths and missing values, as with all methods. So with missing values, the most common strategies are complete case analysis, ignore your missing values and drop them. This is often a problem because, of course, missings tend to be selective. And these typologies, they are, of course, descriptive. And it's important for them, if you compare across countries, for example, that they're population representative. So often you will want to use weights and not just drop your missings. What you can also do is add an additional missing state to your alphabet. And this is often better because then you see, you can look at patterns of dropout. Actually, sequence analysis has been used by survey research analysts to analyze patterns of dropout in surveys. But here you will also see what are the types of sequences that have the most missings, where do they occur, and so on. So at least allowing for some missingness in your alphabet state can be useful. And then there are a variety of ways that you can use to replace gaps with values, so imputation. And here we can, what is often used as just a very simple imputation of forward or backward filling. Let's say I have 1 year of missing information. I just use whatever this person had in the last year or in the next year. But then there are also more complex imputation procedures. For example, Brendan Halpin from the University of Limerick has a program where he developed some sequence imputation that takes into account time constant information, but also information from the temporal structure of the other sequences to do sequence imputation. So there are possibilities here, and you're probably going to have to deal with it depending on your data. So before we have a break and then move to the hands-on, some things to consider with sequence analysis are certainly the computation load. So if you have a very large alphabet of states and very long sequences, so meaning small time intervals and small sequences, the problem is that what we're going to do later on is every sequence is compared to every other sequence, and we have pairwise comparisons. And these then lead to very large pairwise dissimilarity matrices. And so this is basically the bottleneck where then you run into problems with the computation load. So samples of up to 10,000 cases and sequences with the lengths of up to a few hundred time points seem to be quite feasible. Sometimes it needs some computation time, but that works fairly well. And honestly, I think you will rarely need more than 10,000 cases. You can then use random subsamples of your data. So we've seen that with our simulations, with the register data, we really found that above 1,000, the results seem to be quite stable already. Although, of course, if you have a lot of variation in your data, then you would need larger sample sizes to capture that well. Then weight, so most of the tra-minor, that's the package we'll be working with in our functions, allow for using weights in a very simple way. It's not a technical problem so much. Weights can also be used to reduce the computation load, but it's more often a conceptual question of what kind of weights do I want to use. Mostly it's advisable to have weights that combine whatever cross-sectional or design weights you have in your data with then the probability to remain in the sample. So some combination of cross-sectional and longitudinal weights often is your way to go for sequence analysis. But because these typologies are descriptive and we're interested particularly to what extent they are then also representative for given populations or groups, weights are important and you should take them into account here. So let me close this section by reiterating the strength of sequence analysis. So it's really a great method if you're looking for patterns of complex processes over time that are categorical in nature. If you're interested in sequences as a whole, so that you have a holistic processes here, a perspective here on processes as a whole. And it is often most useful if you then combine it with regression-based methods. And this is where reality or the applied sequence analysis has certainly deviated from Abbott's original motivation of really mixing and matching it very fruitfully, I think, with variable-based approaches, rather than seeing these two as entirely different alternative views on the social world. So thanks a lot for your attention. I think we're all ready for a break. Are there more questions I should address before?
I don't think so.